In section 2 of chapter 11, we're going to talk about multiplying and dividing these rational expressions. Again, whenever dealing with rational expressions, think fractions. If I want to multiply 1/2 times 2/3, I simply multiply the numerator times the numerator. 1 times 2 is 2, and the denominator times the denominator. 2 times 3 is 6. Then I always have to reduce. 2 over 6 would reduce to 1/3. And then that's my simplified, multiplied out expression. So here's the rule for multiplying rational expressions. If the numerator is a over b and c over d, we're taking a times c to get ac, and then b times d to get bd. And then at the end, you simplify just like we talked about in the last video. So here's a very simple example. Number 1. If you just multiply across, 4 times 2 is 8. And x to the third times x squared is x to the fifth. And now I look at this and I think, could I reduce that? There are no common factors in the numerator or denominator, so that is my multiplied expression. Example number 2. You can still use groups like x minus 2 or x plus 3, x plus 1, x plus 2. All of these are factors, and they're one group, so you need to remember that. If it's got a plus or a minus, it's one quantity. I'm still going to multiply the numerator times the numerator and the denominator times the denominator. But when you're dealing with quantities like this, it's best to leave them as quantities, at least at the beginning. So x minus 2 times x plus 1 is simply x minus 2 times x plus 1 written as a pair of factors. And in the denominator, you're going to get x plus 3 multiplied by x plus 2 written as a multiplication of factors. The reason we leave it written out like this in factored form is because it's much simpler to check to see if I have any common factors. So now as I look, x minus 2, well, that's not the same as x plus 2, x plus 1, and x plus 3. They're all different. So if all my factors are different, that means this will not be able to simplify, and I can multiply this out now. So I can do my distribution. X times x is x squared plus 1x minus 2x is a total of minus 1x, and then negative 2 times a positive 1 is a negative 2. On the bottom, I get x times x is x squared, x times 2 is 2x, plus 3 more x is 5x, and then 3 times 2 is a positive 6. So this would be my multiplied out simplified expression. And we know it's simplified because we already looked at it in factored form and noticed that none of the factors were the same. So let's look at a third example. On this one, it's better to put everything in factored form before you even multiply. So x plus 2 is already factored. There's no common factor there, so it's going to be x plus 2 over. But I noticed that 3x plus 9 has a common factor of 3. So I'm going to write it in factored form. 3 times x plus 3. And then we're supposed to multiply that expression times another expression, which is x plus 3, again, no common factors there, over, now I'm going to factor this x squared plus 6x plus 8. It's got to be x times x to get x squared, and I know that 4 and 2, both positive, will multiply to 8 but add up to 6 in the middle. So now that it's written in factored form, I can simply multiply numerator to numerator. So x plus 2 is going to multiply by the x plus 3. And in the denominator, I have all these factors multiplying together. 3 times x plus 3 is going to multiply by the x plus 2 times the x plus 4. Now the reason I wrote it in factored form is because it's easier for me to simplify from here. On this example, I do have some things that are going to simplify out. The x plus 2 in the denominator and the x plus 2 in the numerator are going to reduce to a factor of 1. Likewise, the x plus 3 in the numerator and the x plus 3 in the denominator are going to reduce to a factor of 1. So all I'm left with in the numerator is actually nothing, but we don't think of it as 0, nothing. It's no other factors or nothing other than 1. And in the bottom, I was left with the 3 and the x plus 4. I'm okay if you leave it in factored form, or if you just can't handle that and you want to multiply everything out, if you wrote it as 3x plus 12, this would also be acceptable. But the one thing you want to get in the habit of doing is writing everything in factored form so we can clearly see these factors of x plus 2 and x plus 3 being canceled out. Otherwise, you're going to have a lot of multiplying just so you can factor it and then try and simplify it. And you don't want to do all that extra work if you can help it. So what do you do if one of the numbers isn't a fraction? Well, let me give you a very simple example. What do you do when you're taking 1/2 times 4? You probably guessed it. We always think of that 4 as over 1, and then we multiply like normal. 1 times 4 is 4, and 2 times 1 is 2, and then 4 over 2 reduces to 2 over 1, or just 2. So we're going to do the exact same thing with our factors here. We're going to think of 2x squared plus 14x plus 20 as over 1 and continue like normal. I'm going to factor everything. This 3x plus 15 has a common factor of 3 being multiplied by x plus 5. In the denominator, this 2x plus 4 has a common factor of 2 being multiplied by x plus 2. On the numerator of the second expression, I noticed that there's a common factor of 2, so I'm going to bring that out first. Be 2x squared plus 7x plus 10. And I wrote it up there because I'm thinking that that trinomial might still factor. So it's going to be 2, and then it would be x times x to get the x squared. So if you're following along here, I'm just trying to factor this part now, the x squared plus 7x plus 10, with the 2 already brought out in front to make that easier for me. So x times x would give me the x squared, and what I'm seeing is a positive 2 times a positive 5 would give me 10, but also add up to 7 in the middle. So this would be my completely factored form of that numerator. And on the bottom, again, we had put it over 1. So now I multiply straight across, numerator to numerator, denominator to denominator. So I'm just going to write this out. 3 times x plus 5 times 2 times x plus 5 times x plus 2 all over 2 times x plus 2. And again, I didn't even multiply the 3 and the 2 because I just have to simplify it later. I'm noticing that that factor of 2 is going to reduce to 1. This factor of x plus 2 is going to reduce that denominator of x plus 2 to 1. So the only factors I'm left with are the 3x plus 5 and this other x plus 5 in my numerator. So it's going to equal 3 times x plus 5 twice, or 3 times x plus 5 squared. And there was nothing but a factor of 1 left in the bottom, so I don't need to write it as 3x plus 5 squared over 1. I'm actually just going to leave off the 1 and write it as 3 times x plus 5 squared. Again, if you wanted to multiply that out, you could, but I'm not going to make you multiply that out. Let's do 2 more. If we know how to multiply, division of rational expressions is nothing different. So again, let me give you an example in terms of numbers that you should be familiar with. If I wanted to take 2/3 and divide it by 1/2, we hopefully understand that we are going to take the reciprocal of the second number that I'm dividing by and then multiply. So it would actually be 2/3 doesn't change.
Mr. Hammond, please come to the admin office.
And then we multiply by the reciprocal, which would be 2 over 1. So we would end up getting 2 times 2 is 4, and 3 times 1 is 3, and that would be our multiplied out expression, which came from our division. So again, think fractions. If you can think fractions, then everything stays very much the same. You're always going to factor first. So let's write it as x squared minus 4. That would be the difference of squares, x minus 2 times x plus 2. And then I see a common factor of 4 in the denominator, so that'd be x plus 2. Divided by, I have x minus 2 that doesn't factor. I see it's x squared, so that's got to be x times x. A positive 2 and a positive 1 would multiply to 2 but add up to 3 in the middle. So the one thing I haven't done yet is the division. I factored everything. Now division means I need to take the reciprocal of the second number and then multiply. So the first one doesn't change. X minus 2 times x plus 2 over 4 times x plus 2 multiplied now by the reciprocal. So the x plus 2 and x plus 1 are now in the numerator, and the x minus 2 is in the denominator. So now I'm going to write it all together. So it's going to be x minus 2, x plus 2, and then multiplied by the numerator of x plus 2 and x plus 1. All of that is over 4 times x plus 2 times x minus 2 here. So now that it's been multiplied together, I like to simplify from here. I notice an x plus 2 and an x plus 2 that will reduce to 1, an x minus 2 and an x minus 2 that will reduce to 1. I don't see any other factors that are the same. So what I'm left with is the x plus 2 times the x plus 1 over 4. And I'm okay if you leave it just like that. But if you wanted to multiply it out to x squared plus 3x plus 2 over 4, I'm okay with that too. And then one more example. This is called a complex fraction. It looks very, very nasty, but if you think of it as a division bar right here through the middle instead of a fraction bar, this is no different than what we just did. This is the same thing as asking someone to take 2 over x plus 3 divided by 2x plus 4 over 3x plus 9. Well, if I'm dividing, that means I'm going to take the reciprocal of that second fraction and then multiply. So it's going to be 2 over x plus 3 multiplied by the reciprocal 3x plus 9 over 2x plus 4. I didn't do my factoring yet. I decided to take care of the reciprocal part. I did that so you can see that it doesn't matter. But what matters is that you do mathematically correct things. So now let's worry about our factors. 2 over x plus 3 doesn't have any factors to come out. I noticed that the 3x plus 9 has a common factor of 3, so that'd be 3 times x plus 3. And the 2x plus 4 has a common factor of 2, so that would be 2 times x plus 2. Now if you want to save yourself some writing, you don't have to write it all together over one fraction. Sometimes I'll just draw a bar like this because all the stuff on the top is going to end up together on the top, and all the stuff in the denominator is going to end up in the denominator together. But it is a good idea to then throw parentheses around things like x plus 3, so you remember that it's one term. I see a common factor of 2. I see a common factor of x plus 3. So this whole complex fraction that looked very, very nasty at the beginning turned into a division, turned into a multiplication, and then I canceled out my common factors in the numerator and denominator, leaving me just a 3 in the top and an x plus 2 in the bottom. And this is the same exact expression as that complex fraction that we started with up at the top. But it's much simpler to look at it this way. And that's why we simplify. So see what you can do with the examples on your own. Please, please, please ask me questions. This is great practice for your factoring and great practice for working with fractions.